This is my geometry course. Today we're going to continue to learn right triangles, but we're going to focus on the sine, cosine, and tangent ratios. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by learning a new word, trigonometry. The word trigonometry has three parts: tri, which means three, gon, which means shape, and metry, which means measure. So trigonometry is measuring three-sided shapes. That's the general definition of the word. So trigonometry is the study of triangles. But the real-world application of the word specifically deals with relationships between the sides and angles of triangles. So previously in this course, we learned a relationship between the sides of a right triangle. That was the Pythagorean theorem. And we learned a relationship between the angles of triangles. And that was the triangle sum theorem. The sum of the measures of the angles in a triangle must be 180 degrees. Whoops, that last one should be C. So that relates the angles of a triangles. But now, with trigonometry, we're going to study the relationships between angles and sides. That's trigonometry. And why do they come up with that name? Well, I don't know. That's just the traditional name for the study of relationships between the sides and angles of triangles. Now, these equations give us a relationship between the angles and the sides of triangles. That's what we're going to use. These equations are trigonometry. Now, over here you can see we have a right triangle. We first need to explain what this little symbol here means. That's just a symbol for an angle. That's theta. We often use Greek symbols for angles and triangles, or angles in general. Theta. Another one is omega. We use alpha sometimes, we use beta and lambda, and there are many more examples, but those are the most common variables that we use. But theta is one of the most common variables we use, or letters we use to notate angles. Now, like I said, we have a right triangle here, and remember the side opposite the 90-degree angle is always called the hypotenuse. So we already know that that side's called the hypotenuse. But to use these equations, we have to come up with special names for the legs of the right triangle. So this side is called the opposite side in relation to this angle, because it's the side that is opposite that angle. So it's the side across from that angle. It's called the opposite side. Now, both the hypotenuse and this leg here are adjacent to this angle, but this side is always called the hypotenuse. We never call it the adjacent side. But the leg that's next to the angle is called the adjacent side. So that's very important to understand. If you don't really, if you got lost there, that's okay. We're going to do tons of these problems, so you need the hang of the difference between hypotenuse and adjacent side. So the most important thing to understand in this class is that what we're going to learn over here is typically something that makes students very worried. When they see this notation, typically they will become very intimidated, because this notation can be kind of confusing. The goal today in this class is to make you comfortable using this notation. I want you to understand that the concepts that we're going to use with this notation here, some of the concepts are actually from advanced mathematics, but you don't have to learn, you don't have to have a complete understanding of these, how we calculate these expressions in high school or even in college. The goal of this class is to get you to the point where you know how to use these expressions. So just be aware that as we go along here, you might find yourself getting more and more nervous because you think, I don't understand exactly what these symbols mean. I don't get it. But you're not really supposed to get it. You're just supposed to know how to use them, because again, if you want to know how some of these values are calculated, then you would have to go to advanced mathematics in many cases. Actually, in most cases. So the important thing to understand is that these symbols here, even though they look really complicated, they're just symbols. That's it. Just consider them to be symbols that represent ratios. Don't overthink them. Now, this is opposite over hypotenuse. That's what that means. This is adjacent over hypotenuse, and this is opposite over adjacent. That's what those abbreviations mean. So I could launch into a huge explanation of what these functions are and why we use them and so on and so forth, but it's easier just to get started showing you how to do the problems, because like I said, you're not really required to know everything about these functions in a geometry course or even in your entire high school or college education. So I'm going to copy these, and I'm going to bring these with us in pretty much every single problem we do today, because I want you to be able to see these. So I'm going to put those right there. And the best way to learn these, as I said, is just to get started. Okay, as long as you know how to do these problems, then you're fine. So let's get started. It says here, for the triangles below, find sine A, cosine A, and tangent A. Now, I didn't mention this function. This function here is it's pronounced sine theta. Now, it's spelled there sin, but that's just an abbreviation. It's not really pronounced sin or spelled sin. It's actually spelled sine with an E. And this is not cos, it's cosine. And this is not tan, it's tangent. But I'm going to use those words so many times in this class that you're going to start to get used to it without even really having to put much work into it. So we're going to start by finding sine A. So we're going to find A in this triangle. We see A is here. So this angle here is A. And the side opposite that angle is 5, because that's straight across from that angle. It's 5. So we put 5, because sine is opposite over hypotenuse. And then the hypotenuse is opposite the 90-degree angle, or across from a 90-degree angle. So that would be 13. And that's it. Pretty simple. So these problems are really not that difficult. I'm going to write that a little smaller. So now cosine A, that is adjacent over hypotenuse, as you see over here. Again, keep referring back to these yellow expressions there. Cosine A, we're going to look at A, and the adjacent side, there's two adjacent sides. There's 12 and there's 13. Those two sides are both adjacent to angle A. But this is not called the adjacent side, it's the hypotenuse. This is the adjacent side, it's 12. So it's 12 over the hypotenuse. Again, I'm looking at those yellow expressions. It tells us adjacent over hypotenuse. So now we want to find tangent A. So tangent A is opposite over adjacent. So the opposite side of the angle A, right across, is 5. We already said that. So 5. And then it says to divide by the adjacent side. Now, again, this is the adjacent side to A. 13 is not the adjacent. That's the hypotenuse. It is technically adjacent, but we don't call it the adjacent side. So tangent A is 5 over 12. So now we're going to angle B. We're switching angles. It's very important to understand when you're switching angles. Now we're going to angle B. So we want sine B. So sine is opposite over hypotenuse. So opposite of B goes straight across from B, and that is 12. So we write 12. And then over hypotenuse, which we already found multiple times, is 13. And that is sine B. So if you change the angle, things change. Now cosine B is adjacent. So 5 is adjacent to B. Adjacent over hypotenuse, which is 13. So right now, again, you're thinking to yourself, I don't understand this. What is this? What are we doing here? Well, again, it's better just to show you how these expressions work rather than launch into a huge lecture. You just want to know, how do I use these expressions? And as we go along, you're going to learn more and more about them. It's better just to get into the problems rather than to lecture you and have you just fall asleep. Because unless you know how to use these, you're not really going to learn much. So as we go along, we're going to learn more and more about what these expressions are and why we're using them. But now we just have to learn the definition. So tangent B, that is opposite side over adjacent, which is 12 over 5. So opposite of B over adjacent, 5 is adjacent to B. And there we go. All right, so let's do a couple more of these problems before you try some on your own. So in this second triangle, we're looking for sine A. So look at A. Sine is opposite over hypotenuse. Again, looking at the yellow expressions over there. So the opposite side of A is 4, and the hypotenuse is 5. Cosine is adjacent. The adjacent side of angle A is 3, and the hypotenuse is 5. And then we want tangent A, which is opposite over adjacent. So that's 4/3. And sine B, that is opposite over hypotenuse, so 3/5. Now we're changing to B, so the opposite side of B is 3, so it's 3 over 5. And then cosine B is adjacent, so adjacent to B is 4, so it's 4 over the hypotenuse, 4 over 5. And tangent B is the opposite side over the adjacent, so that would be 3/4. All right, let's try one more of these before you try one on your own. So we're going to a different triangle here. Sine A, that's opposite over hypotenuse. So opposite side to A is 5. Hypotenuse is 6. And I want cosine A. Adjacent to cosine is root 11, because cosine, remember, refer back to these. I'm using these as I go along here. Cosine is adjacent over hypotenuse. Adjacent to A is root 11. They want tangent A, which is opposite side over the adjacent, which is root 11. Now this is something where we have to deal with kind of a problem here. Remember, we can't write roots in the denominators of fractions. So we have to multiply both sides by root 11, and we get 5 root 11 over 11. Now, if you don't remember how to rationalize denominators, just go back to my beginning algebra course in the class on simplifying expressions with square roots, or simplifying radicals, or I forget what I call it. There's 2 classes in my beginning algebra course on that. So, see if we got that right. Everything looks right. Sine B is going to be opposite. Now we're going to change the angle. Now we're doing B. So opposite, sine is opposite over hypotenuse, so opposite of B is root 11. And the hypotenuse is 6, so we have root 11 over 6. And cosine B, that's 5 over 6. And tangent B is root 11 over 5. So again, we're just getting used to what these expressions mean. Right now, these expressions mean nothing to you. You're just following this algorithm that I'm showing you, and these expressions. You're using these expressions and learning what they mean. As we go along, you're going to learn more and more and more. But do not be nervous about this. Students have a tendency, like I said, to look at this and just be really afraid and concerned that they don't understand what's going on. Again, these expressions are somewhat advanced, so you're not expected to know much about them until you progress through the math curriculum. Right now, you're just expected to know the definitions of these yellow expressions to the left. That's it. Okay, so I'm going to drag these definitions over here so you can use them, because it's time for you to try some of these problems. So if you need to take a screenshot of the problems that we just did, in fact, you know what? I think I'll just leave these pages in the window as you do number 4. Hopefully you can see number 4. Go ahead and attempt number 4. Now remember, if you're looking for the sine of A, you have to consider A, the opposite side of A, and the hypotenuse, and the adjacent side of A, and all these problems. So we're focusing on A for number 4. So go ahead and try number 4. When you come back, we'll do it together. All right, we're back. So sine is opposite over hypotenuse. So 15 over 17. And cosine is adjacent over hypotenuse. Tangent is 15 over 8. And now we're going to B. So now the opposite side of B, because sine is opposite over hypotenuse, opposite side of B is 8. The hypotenuse is obviously 17. Cosine is adjacent, so adjacent side of B is 15, and over the hypotenuse. And tangent B is opposite over adjacent, so that would be 8 over 15. So if you got those answers, good job. If you made a mistake, that's okay. Just go back and figure out what you did wrong. You should be using those definitions on the right in yellow. So go ahead and try number 5, and when you come back, we'll do it together. All right, we're back. Sine A is 20 over 29. Cosine A is 21 over 29. Tangent A is 20 over 21. Sine B, now we're switching the angle. Sine B is 21 over 29. Cosine B is 20 over 29. And tangent B is 21 over 20. So if you got those answers, good job. So for number 6, be aware that you might have to rationalize the denominator. If you get stuck on that part, that's okay, but you might want to take a screenshot of tangent A there in number 3. You're going to have to do something like that. So go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. Sine is opposite over hypotenuse. So opposite is root 5. Hypotenuse is not 2, hypotenuse is 3. And cosine is adjacent over hypotenuse, so 2 over 3. And tangent would be root 5 over 2. And sine B is going to be 2 over 3, opposite over hypotenuse. Cosine B is going to be root 5 over 3, adjacent over hypotenuse. Tangent B is going to be opposite over adjacent, which is 2 over root 5. And that's the one where we have a problem, because we have to rationalize that denominator. So I'm going to multiply both sides by 2 root 5, and I get 2 root 5 over 5. So if you had trouble with that one, again, go back to my beginning algebra course on the 2 classes on simplifying expressions with square roots. So if you got those answers for number 6, good job. All right, so now we're going to do some more of those problems. Everything that we do today is going to be centered around those 3 definitions. These 3 definitions in yellow here. Now we're just going to do some problems where once you find the ratios, because these are ratios, that's what a ratio is. You're dividing 2 numbers. Once you find the ratios, you're going to have to reduce. So let's do these first 2 together. So sine A is opposite over hypotenuse. Opposite A is 15, and the hypotenuse is 39. Now the difference here is if I divide both of the sides of the fraction by 3, I get 5 over 13. So sometimes you have to reduce. Cosine A is adjacent over hypotenuse. That would be 36 over 39. Divide both sides by 3, and we get 12 over 13. So we had to reduce. Tangent A is opposite over adjacent, so that would be 15 over 36. Divide both sides by 3, and we get 5 over 12. Now we're switching angles. Sine B, opposite side of B is 36, and hypotenuse is 39. Divide both sides by 3, and we get 12 over 13. Again, we're just learning what these definitions are, what these functions are. Cosine B is adjacent, and again, I'm getting this over here. Cosine B is adjacent over hypotenuse, so that would be 15 over 39. Divide both sides by 3, and we get 5 over 13. And tangent B is opposite over adjacent, so that would be 36 over 15. Divide both sides by 3, and we get 12 over 5. All right, let's try one more of these before you try one on your own. Sine A, that's opposite over hypotenuse. But on this one, we can cancel out those 3's. So it just ends up being 1 over root 2. And we have a root in the denominator, so we have to get rid of that denominator, that root in the denominator. So we multiply both sides by root 2, and we get root 2 over 2, and that is our final answer. All right, so now cosine A, that's the same thing, 3 over 3 root 2, because this is an isosceles triangle. So we're just going to get the same answer. Rationalize the denominator. And tangent A is just 3 over 3, which is 1. And cosine B, that's just going to be the same thing. Again, because we have an isosceles triangle. Or sine B and cosine B is root 2 over 2 also. And tangent B is same thing, 3 over 3 is 1. So again, let's drag these definitions over here. Now you're going to try some of those problems. I want you to go ahead and try number 9. And again, you just have to reduce the ratios after you're done using them. So go ahead with number 9, and when you come back, we'll do it together. All right, we're back. Sine A is opposite over hypotenuse, which reduces to 4 over 5. So if you got that answer, good job. Sine A is adjacent over hypotenuse, so that would be 6 over 10, reduces to 3 over 5. Again, I'm using these definitions over here. And tangent A is opposite over adjacent, which is 8 over 6, which reduces to 4 over 3. Now we're moving to a different angle. Sine B is 6 over 10, opposite over hypotenuse, which reduces to 3 over 5. Cosine B is 8 over 10, which reduces to 4 over 5. And tangent B is opposite over adjacent, so that would be 6 over 8, which reduces to 3 over 4. So if you got those answers, good job. If you didn't get those answers, that's okay. Just go back and figure out what you did wrong. All right, so we're number 10. You're going to have to deal with a root. So be aware that you may have to rationalize some denominators. If you get stuck on one of them, that's okay. Try to do most of those problems. And when you come back, we'll do them together. All right, we're back. Sine A, that would be 8 root 3 over 16, and that reduces to root 3 over 2, because 8 over 16 reduces to 1/2. Now you can write 1 root 3 over 2 if you want, but remember, when you have 1 as a coefficient, it's almost never written. It's the same thing as writing 1x as just x instead of writing 1x. So when you have 1 root 3, you can just write root 3. So you can just write it as root 3 over 2. So now cosine A, that's 8 over 16, which reduces to 1/2. Tangent A, that's 8 root 3 over 8. 8 over 8 is 1, so we just have 1 root 3, but we can just write it as root 3. We don't need that 1 like I mentioned. Now we're changing angles. Sine B is opposite over hypotenuse, so that would be 8 over 16, which reduces to 1/2. Cosine B is 8 over root 3, or 8 root 3, over 16, which reduces to root 3 over 2. And tangent B is opposite over adjacent, so that would be 8 over 8 root 3. Now this is a problem where we first reduce, the 8's cancel out, multiply both sides of root 3, and we get root 3 over 3. Again, you can review that rationalizing denominators with square roots in my beginning algebra class, simplifying square roots. All right, so if you got those answers, good job. Now we're going to do the same thing we were doing before. But the difference is we're going to have some slightly different notation. Sometimes you have to learn different notation for the same types of problems. That's just the way it is with math and science and whatnot. Sometimes there's more than one way to write something. So notice that now we don't have in the previous problems we labeled the vertices. We labeled, for example, A, B, C. We were labeling the vertices of the triangle and we named the angles after those vertices. But sometimes you don't do that. Sometimes you actually give a letter that represents the actual measure of the angle. So we have theta there, for example, and we have alpha here. We're using Greek letters now. So the problem says to find the find sine theta, cosine theta, and tangent theta, then find sine alpha, cosine alpha, and tangent alpha. So we're doing the same thing that we did in the previous problems, just with a slightly different notation. So sine theta, that's using this up here, it's opposite over hypotenuse. So the opposite side of theta is root 21 because opposite this angle is 21. And then of course the hypotenuse is opposite the right angle, so that would be 5. So very simple. So cosine theta, that's adjacent over hypotenuse. The adjacent side to theta is obviously 2, and the hypotenuse is 5. So again, I'm using my definitions to the left over there in yellow. Tangent theta is opposite side over adjacent. And now we're moving to alpha. So now sine is opposite over hypotenuse, so opposite of alpha is 2, and the hypotenuse is 5. So we have 2 over 5. And cosine alpha, the adjacent to alpha, is the adjacent side is root 21. So root 21, and then the hypotenuse is 5, so root 21 over 5. Then tangent alpha, that's opposite over adjacent, so that would be 2. Opposite alpha is 2, and adjacent is root 21, so we have a root in the denominator, multiply both sides by root 21, so we get 2 root 21 over 21. So very easy, as you can see. Again, you might be thinking to yourself, I don't understand what we're doing here. Well, you just need to know how to write these ratios and what the definitions are. You don't need to understand exactly what they mean at this point. All right, let's try one more of those problems before you try one on your own. So for this next triangle, starting with theta, so sine is opposite over hypotenuse, opposite of theta, opposite side of theta is 8, and the hypotenuse is 9, so 8 over 9. Cosine adjacent over hypotenuse, so adjacent to theta is root 17 over the hypotenuse, which is 9. Tangent theta is 8 over root 17, and we have a problem. We have a root in the denominator, multiplies by root 17. Over 17. And sine alpha. Now we're changing to a different angle. So alpha, opposite of alpha is root 17, and hypotenuse is 9. And cosine adjacent over hypotenuse. So adjacent is 8, hypotenuse is 9. And tangent alpha is opposite, which is root 17. Opposite alpha is root 17. and adjacent is 8. Okay, so now it's time for you to try some of those problems. Again, it's the same thing that we did in the previous problems. The only difference is we have Greek letters that actually represent the measures of the angles instead of letters that come from the notation for the vertices of the triangles. So I'm going to leave those problems in the window. Why don't you go ahead and try number 13, and when you come back, we'll do it together. All right, we're back. So we need to consider this angle measure here, and sine is the opposite side length divided by the hypotenuse side length. So that would be root 7 over 4. So if you got that right, excellent. 4 is the hypotenuse because it's opposite the right angle, right? Cosine omega would be the adjacent side length, the length of the side adjacent to omega. But 4 and 3 are both adjacent. But remember, 4 is called the hypotenuse. It's not called the adjacent side. So cosine omega is 3 over 4, adjacent over hypotenuse. And tangent omega is the side opposite omega, which is root 7, over the length of the side that is adjacent to omega. So if you got those right, good job. Now we have to move to beta. So sine is opposite over hypotenuse. So the length of the side opposite beta is 3, and the length of the hypotenuse is 4. Cosine beta is the length of the side adjacent to beta divided by the length of the hypotenuse. And tangent beta is the length of the side opposite beta divided by the length of the side adjacent beta. And now we've got a problem because we have a root in the denominator. We're not allowed to have a root that produces an irrational number in the denominator. So we're going to multiply both sides by root 7, and we get 3 root 7 over root 49. And root 49, of course, is just 7. So that's why we did that, is we got rid of the root in the denominator. So if you got that right, excellent. So go ahead and try number 14, and when you come back, we'll do it together. Okay, we're back. So sine omega is equal to the side opposite divided by the hypotenuse. Cosine is adjacent omega divided by this hypotenuse. Tangent omega is the side opposite omega divided by the side adjacent. And now we have to move to beta. So sine is opposite side of beta, which is 4, divided by the hypotenuse, which is 7. And cosine beta is the side adjacent beta, divided by the hypotenuse. And tangent beta is the side opposite beta divided by the side adjacent. And of course we have a problem here because we have a root in the denominator, so we have to get rid of that root. So we're going to multiply both sides by the square root of 33. And so we get 4 square root 33 over, and we could do the math, but we know it's just going to end up being 33. We could multiply 33 by itself, as we did with 7 here, but that would be a big number. So if you got those right, excellent. So in the first problems we did, again, we labeled the angles by the vertices of the triangles. Then we came up with Greek letters to notate the measures of the angles. But in these problems, we actually know what the angles are. We're actually given the angles. So we're going to plug in the actual angles, or actually the angles are already plugged in. So now sine 39 degrees, sine is opposite over hypotenuse, so opposite 39 degrees is y. So we're going to write y, and the hypotenuse is r. So in this problem, we know the angle and we don't know the sides. In the other problems, we knew the sides, but we didn't know the angles. But again, you're just getting used to what these expressions are asking us to find. That's the most important thing in this entire class today. Again, you don't exactly have to know how these are calculated or why they're used yet in this class, but you do need to know what these definitions are. And by the way, we are going to do some applications of these so you can get an idea of how they're used as we go along. So cosine 39, adjacent to 39 is x. So x over r, adjacent over hypotenuse. Tangent is opposite. Is a different angle. So sine 51, opposite 51 is x. And then over hypotenuse, again using the definitions. Cosine 51, adjacent is y. So adjacent over hypotenuse. And tangent 51 is opposite over adjacent, so that would be x over y. So let's do another one of these problems before you try one on your own. Sine 58, the sine is opposite over hypotenuse. So for 58 degrees, the opposite side of 58 degrees is b, and the hypotenuse is c. Cosine 58, that's adjacent. Cosine is adjacent over hypotenuse, so adjacent to 58 is a, and hypotenuse, of course, again is c. Tangent 58, that would be opposite over adjacent, so opposite of 58 is b, and adjacent is a. Now we're moving to a different angle in the triangle. Sine is opposite over hypotenuse, so opposite 32 is a, and hypotenuse is c. Cosine is adjacent over hypotenuse, adjacent to 32 is b, and hypotenuse, of course, is c. Tangent is opposite over adjacent, so opposite 32 is a, and adjacent for 32 is b. Okay, so now it's time for you to try. Again, in these problems, we know what the angles are. So I'm going to leave those problems in the window there. And I want you to try number 17, and when you come back, we'll do it together. All right, we're back. Sine is opposite over hypotenuse. So opposite 59 is k, hypotenuse is n. And cosine 59, that would be m over n. Tangent 59 is k over m. Sine 31 is m over n. Again, I don't want to bore you by just restating these same definitions over and over again. You should see them over here. I don't have to say them for every single problem. So cosine 31 is k over n. Tangent 31 is m over k. So if you got those answers, good job. So the whole point of this is to get used to how to, plug in numbers, whether they be ratios or angles or whatever. All right, so try number 18, and when you come back, we'll do it together. All right, we're back. Sine is opposite over hypotenuse, so opposite 15 is q, and hypotenuse is p. Cosine is adjacent over hypotenuse, adjacent 15 is L, and hypotenuse is P. Tangent is Q over L. Sine is L over P. Sine 75 is L over P. Cosine 75 is Q over P. And tangent 75 is L over Q. So if you got those answers, good job. All right, now we are going to go on to problems where we're going to need a calculator. So for these problems, you can use the calculator on your phone. You can use a calculator on your iPhone or your Android or whatever phone you have. You can use the calculator on your computer, though that's going to be kind of tedious having to go back and forth on your computer. If you're doing your work on paper, though, it wouldn't be too bad. You can use a calculator, Texas Instruments calculator, a Casio calculator, whatever you want to use, but your calculator has to have the buttons sine. The button is going to have that. You need cosine and you need tangent. So if your calculator doesn't have those, if you're just using a very simple calculator without those buttons, that's not going to work. Now you need to understand that when you use an iPhone, I don't remember how Android calculators work, the built-in calculators, but with the built-in iPhone calculator, you're going to have to turn the phone into landscape mode. Because when you use it in normal mode, those buttons are not going to be there. So turn it over to landscape and you'll see a bunch of buttons there. And you're going to see sine hyperbolic. You're going to see regular sine. You're going to see sine -1. For now, don't use the sine hyperbolic or the sine -1. We're just looking for sine and regular cosine and regular tangent. Another extremely important thing that you need to know before we start using the calculators is that you need to make sure that you're in degree mode. Okay, there's two kinds of angles. There's degrees and radians. So radians looks like that, and degree mode looks like this. So sometimes if your calculator, if an iPhone says rad, that means you're in degree mode. If there's a button that says rad, that means you push that button and you go into radian mode. So it can be very confusing, but you're gonna see exactly what mode you're in, because if you start getting the wrong answers, you're gonna know I'm in the wrong mode. So you have to figure out how to change the mode. So we're going to use our calculator to find sine 82. Now I need to explain something real quick. As I said, as we go along here, you're going to learn more and more about what these expressions actually mean. So let's say you have an 82-degree angle in your triangle, your right triangle. Again, these expressions only refer to right triangles. I don't know if I emphasize that, but sine, cosine, tangent, they only refer to right triangles. So we know two of the angles. We know 82 degrees, and we know this angle is a right angle. Now, the important thing to understand is that sine, cosine, and tangent, as you can see, they are ratios. So what that means is it doesn't matter how big or small this triangle is. If you know these two angles, then by the triangle sum theorem, that automatically defines this angle. So if you know those two angles, you know the relations between the sides. At least, well, you don't really know them, but the calculator knows them. So if you take this side, the opposite side, and divide by the hypotenuse, that ratio is going to be the same no matter how big or how small the triangle is. Now, I know that's a lot to take in, and if you don't understand what I meant by that, it's okay. Again, most students really don't understand what I just explained, but I want you to get a little bit more than students get normally in classes. But all you have to know is how to calculate this in your calculator. So it's very easy. We just have to plug in that 82 degrees and we can find the ratio. We don't need to actually know the sides to find the ratio. So here's what you're going to do. Now I'm using an iPhone. If you use an Android or a different calculator, you might have to do this in a different order. If you get your iPhone ready there, put it in landscape mode, and you're going to push the button. You're going to push 82. Then you're going to push the button on the bottom left, near the bottom left, that says sine. And that is going to give you your answer. So it's 0.99026.8 0687. It just keeps going on forever. Okay, that it'll never stop. So we have to round off. And now, before we do that, I want you to know that if you're using an Android phone, you have to do it backwards. First, you push sine, and it might have like a parenthesis there. Then you write 82, and then you push enter. So with an Android phone, it might be different, and it might be different if you're using a Casio or a Texas Instrument. You might have to put the sine button first. But with an iPhone, you have to put 82 first, then push the sine button. That's the way it is with a lot of calculators. So I'm going to go ahead and calculate cosine. So 82 first, then I'm going to push the cosine button, and we get 0.13917310096, and it just keeps going on forever. And tangent 82, I'm going to push 82, then the tan button. Now be very careful not to push those other buttons. Don't push the sine H or cosine H or tan H. That would be very bad. Also, if you accidentally push the second button, you're going to see buttons like sine -1. Don't push that button. That's wrong. That's going to give you the wrong answer. But tangent, that's going to be 7.115369 and 722, and it just keeps going on and on. So now we have to round these numbers off. It says round off to 4 decimal places. So we learned rounding in my arithmetic course, but you may be a little rusty on it. So we're going to go 1, 2, 3, 4 decimal places. So 2 is going to be the last number. In order to figure out if we round up or down, we look to the number next to 2, which is 6, and 6 tells us to round up. So that makes the 2 go up to 3, and all these other numbers disappear. So now we can say sine is approximately equal to 0.9903. We have to approximate because the number just goes on forever. That's why these ratios are not easy to calculate in most cases, because we have what's called an irrational number. It just goes on forever and ever. You need advanced mathematics to calculate that ratio. But in this class and in your entire K-12 education, you don't need those advanced mathematics. You just need a calculator. That's all that's required in any high school or any college, pretty much. In well, not college, but in high school. And for most kids, really in college, that's the way it is also. So now we're going to round off our cosine number. So we want, again, 4 decimal places. So 1, 2, 3, 4. So that 1 is the 4th decimal place. And we look to the number next to 1, which is 7. That tells us to round up. So we get 0.1392. The 1 goes up to a 2. And that's our final answer for cosine 82. Again, the ratio is the same no matter how big or small the triangle is. We just define that angle as 82, and then we can get the ratio. So now we have 1, 2, 3, 4, and we go over 1 to 6, and that tells us to round up. So it becomes get rid of that line, 7.1154. And the reason that we're rounding up on all these is because the numbers next to the 4th number, 6 is greater than, it's greater than 5, and 7 is greater than 5, so we round it up, and 6 is greater than 5, so we round it up. So it's just by coincidence these numbers all ended up being rounded up, but that's not the case in the next problems that we're going to do. So let's try sine of the 25-degree angle. I'm going to put a little divider here. So again, just use the calculator. You plug in 25 and then push the sine button. And so we get 0.42261. 8, and we can just keep going on and on. So we have to round off. And by the way, these should be squiggly lines too over here. Technically, even though because I didn't write all the numbers, so it's got to be squiggly on all these. So squiggly line, squiggly equals there. So we're going to round off, and we get 4226, 0.4226. And in that case, we rounded down. So the reason we rounded down is because this 1 here tells us to round down. So 6 just stays there, and the other numbers just disappear. Again, all the other numbers, they always just disappear. So if you don't remember this rounding stuff, you can go back to my arithmetic course, and there's an entire class on rounding. All right, so cosine 25, again, get your calculator out. And we're going to plug in 25 and then the cosine button. So we get 0.9063, 0.77, on and on. But we're going to round off. And we rounded down again on this problem because the 5th decimal there was 0. So that told us to just round down. So we just kept the 3 there, and all the other numbers disappeared. So now I'm going to plug in 25 and then push the tan button, the tangent button, and we get 0.466307, and on. And then finally I'm going to round off to 0.4663 because the 0 tells us to round down. So that's how to use your calculator to find the actual ratios. So in this case, we don't actually need these yellow expressions, but I'm just going to carry those with us as we go here. So now it's time for you to try. Go ahead and try number 21. Again, you're going to have to use your calculator, and you're going to round to 4 decimal places. And if you need help with that rounding, go to my class and my arithmetic course on rounding. So try 21, and when you come back, we'll do it together. All right, we're back. I'm going to type in 49, then push the sine button. And we get approximately 0.754709, so on and so forth. And if we round off, we get the following. So if you got that answer, good job. All right, and now I'm going to type in 49 to my calculator and push the cosine button. And we see it's approximately 0.656, 0.59, so on and so forth. So then we're going to round off, and we get 0.6561. That 5 tells us to round the 0 up to 1, and all those other numbers go away. And then I'm going to plug in 49, push the tan button, and I'm just going to go ahead and round off because we don't have enough room here. So 1.1504. So if you got those answers, good job. So go ahead and try number 22, and when you come back, we'll do it together. All right, we're back. So again, we're using our calculator. So type in 17 and push the sine button and round off to 4 decimal places. So that's going to be 2924. I'm not going to explain the rounding. I'm just going to go, because again, you should know how to round by the time you get to this course. 17, pushing cosine, 0.9563. A lot of students are going to say, well, why don't you explain rounding? I want you to explain rounding to me. You're not a good teacher because you don't explain rounding. Well, that's not the way math works. Again, there's a lot of prerequisites for this course. You're expected to know how to round by the time you get here because we can't cover everything in the entire math curriculum in this one course. There are 3 courses before this course, and so you can't cover all that material in this course, so we just can't go over everything and review everything. we have to go back to my arithmetic course. So now tangent 17. 17, press tangent, and we have 0.3057. And there you go. So if you got those answers, good job. Okay, so that was how to find the trigonometric functions using a calculator. That is trig ratios using a calculator. These functions are called trig ratios. They're called trigonometric functions. There are a lot of names for them. Now we're going to find the trig ratios without a calculator because we have special angles. Remember 30, 60, and 45, those are special angles. When you have special angles, you don't need a calculator. So remember sine 60, we're going to demonstrate what I mean here. Sine 60, that's opposite over hypotenuse. Remember, I have my definitions over here. If you forget those, we'll always refer to those. Sine is opposite over hypotenuse, so the opposite side of 60 is x root 3. And the hypotenuse is 2x. So it doesn't matter how big or small this triangle is, those x's are going to cancel out. So we have root 3 over 2. Now you might be thinking, wait a second, x's cancel out? What does that mean? Well, that's just pre-algebra stuff. Remember, if you have like x cubed over x to the 5th, it just reduces to 1 over x squared. Again, this is all pre-algebra stuff. On the other hand, if you have x to the 5th over x squared, it reduces to x to the 3rd, so on and so forth. But if you have x over x, that just cancels out and becomes a 1. So those two x's just cancel out, they become 1, and they disappear. So this is what I meant before when I said it doesn't matter how big or small this triangle is, the ratio is going to be the same. The ratio of the opposite side and the hypotenuse, given one of these acute angles is 60, we only need to know one because the other one is defined immediately by the triangle sum theorem. If we know that angle, then the ratio is going to be the same no matter what. And again, if you understand that, great. If you don't, that's okay. These are pretty advanced topics, but we don't need a calculator for these special angles because we know the relation between the sides. Now, if you want to know the relation between the sides in a triangle where you have an 82-degree angle, that is not easy. Those are irrational numbers. Those are decimals that just go on forever. So that's why we need a calculator for those. But for this triangle, we don't need a calculator. We know the relation between the sides. So cosine 60 is adjacent over hypotenuse. Those cancel out, those x's cancel out, and you're left with 1/2. Tangent 30 is opposite over adjacent, and opposite of 30 degrees is x, and adjacent is x root 3. So if you cancel out those x's, you get 1 over root 3, multiply both sides by root 3, and you get root 3 over 3. Remember, you can't have a root in the denominator. Okay, so now it's time for you to try. Go ahead and calculate sine 30. Remember, you want sine is opposite over hypotenuse, so you want opposite over 30 is the x, and the hypotenuse is 2x. Sorry about that, my computer's jumping around. So go ahead and try sine 30. When you come back, we'll do it together. All right, we're back. Sine 30, opposite is x, hypotenuse is 2x. Reduce those x's or cancel them out, and you have 1/2. So cosine 30, go ahead and try that one, and go ahead and try tangent 60 also. When you come back, we'll do it together. All right, we're back. Cosine 30, adjacent to 30 degrees is x root 3. Hypotenuse is 2x. X's cancel out, and you're left with root 3 over 2. If you got that answer, good job. I'm going to move these over a little bit. And tangent 60 is opposite over adjacent, so opposite is x root 3. And adjacent is x. X's cancel out, and you're left with root 3. So if you got those answers, good job. So let's try a 45, 45, 90 triangle. These are also special angles. Now, this is going to be a little confusing because both of these angles are 45. This is an isosceles triangle. So when you consider what angle you're gonna factor in, it doesn't really matter which one you choose. You're going to get the same answer. So let me bring these definitions down. And go ahead and try number 25. And when you come back, we'll do it together. All right, we're back. Sine is opposite over hypotenuse, so I'm going to look at this angle, consider that angle. So opposite would be x, and hypotenuse is x root 2. X's cancel out. You have 1 over root 2. Multiply both sides by root 2, and you get root 2 over 2. So if you got that answer, good job. And cosine 45, same thing, because it's an isosceles triangle. X's cancel out. Rationalize the denominator. Tangent 45, that's just going to be opposite over adjacent. X over x is just 1. So if you got those answers, good job. Okay, so now we're going to use these relations for what they're actually intended for. We're getting to some actual real-world applications. We're not going to see exactly what in the real world they're used for, but these are the kind of problems where you'd actually use trigonometry. So notice that we have right triangles. Again, these functions only they're only applied to right triangles. Well, actually, they're applied to other triangles, but these functions alone in their current form are only for right triangles. So this is what this math is actually intended for. Remember, these expressions are relations between the angles and the sides of triangles. Okay, relations between the angles and the sides. We learned the Pythagorean theorem. That's a relation between the sides. We learn the triangle sum theorem. That's a relation between the angles. But now we have a relations between the sides and the angles. So we're given angles and sides, and we're going to use that information to find a missing side. So I'm going to try to use sine 65. Sine 65 is opposite over hypotenuse. Whoops. We don't have any information about the hypotenuse. In fact, we're not even looking for the hypotenuse. So we can't use sine. Let's try using cosine. Cosine 65 degrees is equal to adjacent over hypotenuse. Whoops. We can't use that either. So you know what's going to happen. It's got to be tangent. So tangent 65 degrees, that would be opposite over adjacent. Now we have the information that we're given and the unknown that we're looking for, because it says we want to find x. So at this point, we're just going to solve for x. We have to isolate x. We have to get it by itself, just like the one-step problems we learned in pre-algebra. So to get x by itself, we have to get rid of this 4, because x is not by itself. It has a 4 next to it. Now that's x divided by 4, so we have to do the opposite of division, which is multiplication. The 4's cancel out. We have x is equal to 4 times tangent 65 degrees, and we can just get rid of those parentheses. Now tangent 65 degrees, we can figure out what that is. Again, it doesn't matter how big or small the triangle is, the ratio of the opposite side over the adjacent is going to be the same. So go to your calculator and punch in 65 and then the tangent button, and then times 4 equals. That's the easiest way to do it in your iPhone calculator. It might be different for your Android calculator or Casio or Texas Instruments, whatever. So it says round to 4 decimal places, so we have 8.5780. We don't really need that 0, but we can just write it there. It's important to understand that if you're using an Android phone, you might have to plug in the 4 first, then push tan button, then 65. So it's different depending on what calculator you're using. But if you're using the iPhone, I'm warning you, if you don't do it in the order that I did it, first plug in the 65, then push the tan button, then push the times button, and then 4, and you're going to get your answer. If you don't do it that way, things are going to get complicated. There might be another way to do it, but that's just the way that is easiest that I know of. It might work if you push 4 times 65 and then the tan button, then equals. That might work also. All right, so let's try 27. I'm going to try sine 38 degrees. That's equal to opposite over hypotenuse. Whoops, we don't have the opposite side, so we can't use sine. So let's try cosine. Cosine 38 degrees is equal to adjacent over hypotenuse. We did it. That's correct. So now cosine 38 degrees, we're going to isolate x. X is not isolated. The reason it's not isolated is because the 9 is next to it. We have to get rid of the 9, so we have to do the opposite of division because that's x divided by 9. And then we end up with x is equal to 9 times cosine 38 degrees. So now we just have to get our calculator and approximate what that would be. So I'm going to plug in 38, then push the cosine button, then times 9, and then equals. So I get 7.0921 if I round off. Let's try one more of those problems before you try one on your own. For this problem, I'm going to try sine 70 degrees. That's equal to opposite over hypotenuse, and it looks like that works. But this problem is different because the variable is in the denominator. You can't solve it very easily. So in my experience, students prefer the cross multiplication method, so I'm going to write sine 70 as over 1. Remember, if you have any expression well, pretty much any expression you can write as over 1, you can turn it into a fraction if it's not already a fraction. So now we're going to cross multiply, if you remember the cross multiplication method used in my arithmetic course. We're going to cross multiply. So 2 times 1 is 2, and x times sine 70 is just x times sine 70 degrees. So now we need to get x by itself. So we're going to divide, we're going to get rid of that sine 70. And I know what you're thinking, this is getting really complicated. Well, it's just basic algebra. The only difference is you're moving around this sine 70 thing, which is unfamiliar to you, but it's just basic algebra. So it's nothing to be afraid of. So now those cancel out. We get x is equal to 2 over sine 70 degrees. So now we just have to calculate what that would be. And you're going to need to do this in your calculator very carefully because there's a lot of room for error. So we're going to write 2, or push 2 in our calculator, then the divided by symbol, then 70, then the sine button, then equals. Again, if you have an Android or a Casio or Texas Instruments calculator, you might do it differently. So we get 2.1284. So that was kind of a tricky problem because, like I said, the variable was in the denominator of that fraction. So I'm going to grab our definitions here, bring that over for you. And now I want you to be aware that the rounding is going to be kind of weird on this problem. So just be aware of that. It's going to be kind of an advanced rounding problem. But go ahead and try number 29, and when you come back, we'll do it together. All right, we're back. I'm going to try sine 43 degrees, and it turns out that that works. Opposite over hypotenuse. And I'm going to multiply both sides by 6 to isolate x. And we have x is equal to 6 times sine 43 degrees. And x is approximately equal to, so we get out our calculator, 43 degrees, then push the sine button, then times 6 equals. So we get 4.092. Again, that was kind of a weird problem with the rounding there. So if you got that answer, good job. All right, on to number 30. Go ahead and try another one of those problems. And when you come back, we'll do it together. All right, we're back. I'm going to try sine 50 degrees. That's opposite. Whoops, we don't have opposite. Can't use sine. So now let's try cosine 50 degrees. That's adjacent over hypotenuse. So it looks like that works. So now we're going to multiply both sides by 22 to isolate x. And we get 22 cosine 50 degrees equals x, and x can be approximated with a calculator. So push, in an iPhone, you push 50, then the cosine button, then times 22. And we get 14.14 and 1/3. So if you got that answer, good job. All right, so for 31, you might want to take a screenshot of number 28 that we did there, because that's going to have a variable in the denominator. So go ahead and try number 31. Remember, you have your definitions over here in case you forget. That's what this class is all about, these definitions. So try 31, and when you come back, we'll do it together. All right, we're back. I'm going to try sine 37 degrees. That is 7 over the hypotenuse. We don't have the hypotenuse, so can't use that. And the cosine uses the hypotenuse too, so we can't use that. So I'm going to have to use tangent 37 degrees. That's opposite over adjacent. Now I'm going to write tangent 37 over 1, just because we're using the cross multiplication method. You don't have to use this method. There are other methods, but students prefer generally the cross multiplication method. So now we're going to cross multiply, and we get 7 is equal to x times tangent 37 degrees. And we still need to isolate x. Remember, this is the tricky problem, so we're going to rewrite, and we're going to get rid of that tangent 37, so x is by itself. So we're going to divide both sides by tangent 37. And the tangents cancel out on the right side of the equation, and we have x is equal to sine, or 7 over tangent 37 degrees. So now all we have to do is get the calculator. Remember, this can be tricky, so be careful. In an iPhone, you do 7 divided by 37, tangent button, and then equals. And so we get x is approximately equal to 9.2893. So if you got that answer, good job. All right, so we're getting more into the actual applications of how these functions are used. But now we're really getting into some applications. You're really going to have a better idea of how this is used in these next problems. We're going to learn an application that's called angle of elevation, and also we're going to learn angle of depression. So let's say that you're walking down the street and you're looking straight ahead, but then there's a bird that flies over your head, or flies up here. Can't really draw a bird. And you look up. You start from the horizontal and you look up to the bird. Whatever that angle is that you rotated your head, that's called the angle of elevation. All right. Now it's important to understand that you start at the horizontal. You always start at the horizontal and rotate up to what you're looking at. Now let's say that there's something on the ground. Let's say you're about to hit a fire hydrant or something, and you look down at the fire hydrant. That's called the angle that you rotated your head. That's called the angle of depression. That's depression. Now again, it's very important to understand you start at the horizontal and then you go down to what you're looking at. So that is angle of elevation and angle of depression. And we're going to use those concepts in these next problems. So let's read this word problem. You stand 100 feet from a building and you measure the angle of elevation from the ground to the top of the building as 41 degrees. So if you're down here and you look up to the building, from the ground, the angle of elevation is 41 degrees. Now, in the previous problem, we were going from your head. We're looking straight from your head, but if you actually do the angle of elevation from your head, that's going to complicate things. So we're just going to do the angle of elevation from the ground. So the angle of elevation from the ground is 41 degrees, and that's from where you're standing, and you're 100 feet away from the building. So what we're going to do is we're going to consider a triangle, this triangle here, and in that triangle we know that this is a 90-degree angle, and this is 41 degrees, and this side is 100. So this is going to be just like the problems we just did. And by the way, this is going to be x over here. That's the height of the building. We're looking for the height of the building. That's the unknown. So like I said, it's just like the problems we just did. Now, how do we know that that's a 90-degree angle? Well, we know it's a 90-degree angle because buildings are not built so that they're diagonal like that. If they were built that way, they would probably fall down. So we just know that that's a 90-degree angle. So I'm going to take out that triangle and write it over here. So we have 41 degrees, this side is 100, and we're looking for this side. I'll just call that h because it's the height. So now we're just going to do the exact same thing, and by the way, this should be 90 degrees. We're going to do the exact same thing we did in the previous problems. It's pretty simple. So I'm going to use tangent. 41 degrees is equal to opposite over adjacent, and then I'm just going to solve. So tangent 41 degrees, multiply both sides by 100, and we get h is equal to 100 times tangent 41 degrees. And now we have to get our calculator out. So 41, then the tangent button, then times 100. And by the way, I'm just saying tan because that's what you see in your calculator. That's not really how it's pronounced. It's pronounced tangent. So we have 86, and how many decimals? It says round to the nearest whole number. So it's just going to be 87 feet. So the building is 87 feet high. All right, let's try another one of these problems. And as usual, I'm going to drag my functions down here. I can't lose those functions. Now we have a helicopter. The helicopter is flying, and the guy that's in the helicopter, he turns his head down to look at this boat, and the angle of depression of his head is 32 degrees. And we know that the helicopter is, or the guy in the helicopter is 80 feet off the ground. So this is going to be a little bit weird because there are two triangles that we can use. In fact, there were two triangles we could use in the previous problem. We can use this triangle, or we can use this triangle. Now I'm going to use this triangle because that triangle has the angle inside it. Turns out we can actually find this angle very easily because these 32 and this angle, they add up to 90 degrees. And if we want to do, we could find this angle very easily. That would end up being 32 degrees using math that we learned in previous classes in this course, but we're just going to stick with the upper triangle. But just be aware that there's many different ways to do this. All right. So I'm going to pull out that triangle. Again, it's the upper triangle. And I know this angle is 32 degrees. And this angle is a right angle. And now we don't have the other side. We don't have any side of this triangle. But actually, this side here, we can just carry it over here. And that's going to be 80 also. So again, that's kind of a tricky part of the problem. So this side is actually 80. And this problem is asking for the horizontal distance from the helicopter to the boat. So that's that length, which is the same as this length. So in our triangle, we're going to write, that's going to be our variable, and we can just call it x. So I'm going to write x there. And now it's just the same type of problem we did before in the previous multiple problems. So let's see here. It looks like we're going to use tangent. So tangent 32 degrees is equal to opposite over adjacent. But now we have a variable in the denominator, so this is going to be a little bit more involved. So I'm going to write tangent 32 degrees over 1. So we can use cross multiplication and cross multiply, and we get x times tangent 32 degrees is equal to 80. And then I'm going to divide both sides by tangent 32, and the tangents cancel out, and we can't really go right to left, so I'm going to move this over. We can write an arrow. Remember, if you ever run out of room, that's going to happen a lot. So you have to write an arrow. So x is equal to 80 over tangent 32 degrees. So now we just get out our calculator, and x is approximately equal to, so remember, you have to do this in the right order. We're going to write 80, then divided by 32, press a tangent button, then equals. So rounding off to the nearest whole number, we have 128 feet. So that's the horizontal distance to the helicopter. That's this distance here. All right, we're going to try one more of these problems. Number 34, it says, for problem number 33, what is the length of the shortest path from the helicopter to the ship? Round to the nearest whole number. So the length of the shortest path, if the helicopter wants to go the shortest path, that would just be directly to the boat. That is the hypotenuse of that triangle. So now we have the same triangle. We're just looking for the hypotenuse of the triangle rather than one of the legs. So I'm going to redraw that triangle. And the hypotenuse is what we're looking for. I'll call that x. And we know that this side is 80. So we have to figure out what ratio we're going to use, and it looks like we can use sine. So I'm going to use sine 32 degrees is equal to the opposite side over the hypotenuse. And again, same situation. We're going to write sine over 1 because we've got x in the denominator. And we're going to cross multiply. 80 times 1 is 80. And x times sine 32 degrees is x times sine 32 degrees. Then we're going to divide both sides by sine 32 degrees to isolate x. Then we get x is equal to 80 over sine 32 degrees. So now we can just approximate x with the calculator. So again, be careful how you do this. It's 80 divided by 32 sine button equals. So we have 151 feet. So those are some real-world applications of trigonometry, which again studies the relationships between angles and sides of a triangle. So again, why would we use this? Well, what if you couldn't get up to this building? What if you couldn't go up to the top of the building? Then you couldn't measure the height of the building, you see. But it might be pretty easy just to measure how far away you are from the building. And if you had an instrument that measures angle, then you can measure the angle that you have to look up to get to the top of the building. Engineers do this all the time. So with this angle and this length here, you can figure out how high the building is without actually going up into the building. And that's extremely important for engineers and sometimes for scientists. And you have other examples we showed for 33 and 34. But now it's time for you to try. So if you want, you can take screenshots. Take a screenshot of this problem. That'll be very similar to the one you're about to do. So go ahead and try this rocket problem. And when you come back, we'll do it together. All right, we're back. So I'm going to draw the triangle. We know this side is 400, and we're looking for, that's x, that's what we're looking for there. So now I'm going to use tangent 35 degrees is equal to opposite over adjacent. And as usual, we're going to solve by writing over 1. Then we're going to cross multiply. And you don't have to write this cross multiplication stuff. I'm just doing it so you can see what's going on here. So then we get x times tangent 35 degrees. And now we just have to divide both sides by tangent 35. So again, if you run out of room, that's okay. Just put an arrow. Divide both sides by tangent 35. And x is equal to 400 divided by tangent 35 degrees. Therefore, x is approximately equal to, so again, be very careful how you enter this into your calculator because there's a lot of room for error. 400, then the divided by button, then 35, then the tangent button, then equals. And we get 571 meters. 571 meters. And be sure to write your units, the meters there, or else the problem's not correct. So if you got 571 meters, good job. All right, so on to another problem here. Now for this problem, I have to warn you, again, it gets tricky. It's just like the helicopter problem. It can get kind of tricky. We could use this triangle, which is actually the triangle we're going to use, or we could use this triangle. But again, we're going to use this triangle because then the 72-degree angle, we're going to use this triangle because the 72-degree angle then is inside that triangle. So I'm going to go ahead and, well, you can write it yourself, but also I want you to understand that if we use this triangle, then we have, we're looking for this height, but that's not a side of that triangle. And we're looking for, we have this length, but that's not a side of the triangle. So how do you deal with this? Well, again, remember with the helicopter problem, you can take this length and just transfer it up and it becomes this side of the triangle. That's just the way that works. So 24 is going to be this side of the triangle. So when you draw your triangle, be sure to write 24 as an adjacent side to 72. And also, again, we're trying to look for the height of the cliff. So this is the height of the cliff over here. You can just take that and transfer it over, and that becomes this side of the triangle. But that's our unknown, so that's going to be, you can just call that h. So that's the triangle that we're dealing with. So go ahead and try this problem. And when you come back, well, wait a second. I forgot to bring our functions over here. I'm sorry about that. I should have brought the functions. So go ahead and try number 36, and when you come back, we'll do it together. All right, we're back. So I'm going to draw the triangle. And this is 24, and this is the height we're looking for. So now I'm going to set up, it looks like it's going to be a tangent. So tangent 72 degrees is equal to h over 24. And we're just going to multiply both sides by 24. This problem is a little easier. That cancels out the 24s, so we have h is equal to 24 tangent 72 degrees. And we're going to need to use the calculator to approximate. So again, with an iPhone, you plug in 72 degrees, then the tangent button, then times 24 equals, and it's going to be 74. So the cliff is 74 feet high. All right, so if you got that answer, good job. So let's do one more of these word problems. So this one's pretty standard. So go ahead and try 37, and when you come back, we'll do it together. All right, we're back. So I'm going to draw the triangle. And we're looking for the length of the string. So now we're looking for the hypotenuse. So we can just call that x. And it looks like we're going to use cosine. That's going to be the ratio of the function to use. So cosine 30 degrees is equal to adjacent, which is 120, over the hypotenuse, and that hypotenuse is what we're looking for. So cosine 30 degrees, that's actually a special angle, so we don't really need a calculator, but just so you can see that the calculator is going to give us the same answer, we'll go ahead and just use the calculator for that. So we're writing cosine 30 over 1. And then we're going to cross multiply. And then we get x times cosine 30 degrees is equal to 1 times 120, which is 120. And put an arrow up here. And we're going to divide both sides by cosine 30. So x is equal to 120 over cosine 30 degrees. And that means x is approximately equal to 120 divided by 30, cosine button, and then equals. So we have 139 feet. So if you got that answer, good job. So that is the length of the string. It's 139 feet. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework and to study for tests, go ahead and do that now. We have screenshot number 1, screenshot number 2, screenshot number 3, and screenshot number 4, and screenshot number 5, screenshot number 6, and screenshot number 7. And screenshot number 8. And screenshot number 9. And screenshot number 10. And don't leave before you get the homework. And you might want to take a screenshot of this little picture here if that helps you understand angle of elevation and angle of depression. But now let's go to the homework. Remember, if you don't get that homework done, it's a 100% guarantee that you're going to learn absolutely nothing in the entire course. So this is screenshot number 1. Screenshot number 2. And we have 2 pages for the answers. Screenshot number 3. And screenshot number 4. So get that homework done completely and correctly and neatly, and be sure it's in the correct chronological order in your binder. And I'll look forward to seeing you in the next class.